Hi here for Clan Maths. Today we're going to look at National 5 Maths expanding brackets. We're going to go through the whole expanding brackets, including all the past paper questions, everything you need to know to be successful at expanding brackets. So let's start off with expanding single brackets. Expand 6 bracket t plus 5. Now there's a number of ways you can think about doing this, but I like to think about the area method, basically drawing a box. So whenever I want to expand a bracket, I draw a box. On one side of the box, I put the first thing, which is 6, and then I'm timesing by t plus 5. So I separate the t and the 5, and then I just times everything together. 6 times t is 6t. 6 times 5 is 30, so it's plus 30. So my answer outside the box is 6t plus 30. And I'm done there. Simple example. Another example with a negative expanding single brackets. Expand negative 3 times d plus 6. So I'll draw my box. We've got minus 3 times d plus 6. So minus 3 times d is minus 3d. Minus 3 times 6, well I just do 3 times 6 is 18. So it's minus 18 because a minus times a plus is a minus. So the answer is minus 3d minus 18. And we're done there. Another expanding single brackets question. Expand 5x bracket 2t minus 3u. So I draw my box. Don't worry about all the different letters. 5x 2t minus 3u. Split my box in two. 5 times 2 is 10. X times t is xt. So 10xt. 5 times 3 is 15. So it's minus 15. X times u is xu. So I get 10xt minus 15xu, and we're done there. Okay, let's look at ones where there's the same letter appearing twice. 7y bracket 4y plus 3t. So there's my box. 7y, 4y plus 3t. So it's numbers first. 7 times 4 is 28. Take your time on that. Y times y is y squared. So watch out for squares or cubes appearing. 7 times 3 is 21. So it's plus 21. And it's y and t. So it's y and t. 28y squared plus 21yt. And we're done there. Expanding and simplifying. First of all, I'm going to look at ones where I've got 3 terms. So I'll draw a big box. 7, 3a plus 4b minus 5t, split, split. 3 answers, 3 things in the brackets. 7 times 3 is 21, a. 7 times 4 is 28, so 28b. 7 times 5 is 35, so minus 35t. So I can write that outside the box, 21a plus 28b minus 35t. No like terms, so I'm done there. Let's look at ones with a negative number in front. Minus 3 plus y. So it looks like there's no number. So if it isn't a number, it's 1. So it's minus 1. 3 plus y. And this will help us to expand and simplify brackets in a minute, because minus 1 times 3 is minus 3. And minus 1 times y, what's 1y? So it's minus y. So that gives me minus 3 minus y. So looking at questions where you have to expand then simplify, you get a question like this. How I'd set this up is, I'd say I've got 7t, well that's not a bracket, so I'll just write it, minus, and I'm going to go a box, because I've got a bracket, minus 3t minus 5, expand, watching out for minus times a plus and minus times a minus, minus 3 times t is minus 3t. Minus 3 times minus 5, a minus times a minus is a plus, so plus 15. So now you should be able to see that I've got, putting it outside the box, I've got my 7t at the start minus my 3t plus 15. So I can collect the like terms. 7 minus 3 is 4. So I've got 4t plus 15. And we're done there. Let's look at another example like that with 2 brackets. So the first one is 7, 3x minus 2. Take away 5. Box 4x minus 3. Now it gets really easy, because once you've got your boxes in place, you'll be able to see it all. 7 times 3 is 21x. 7 times 2 is minus 14. Minus 5 times 4 is minus 20x. Minus 5 times minus 3 is plus 15. So you should be able to see that we have got inside the boxes 21x minus 20x. So I can immediately write x. And then looking at the number parts, minus 14 plus 15. 15 minus 14 is 1, so it's plus 1. So our answer, without much extra work, is x plus 1. And we're done there. Let's look at another example like that for expanding and simplifying single brackets. 6, 4y plus 1. Split it. Minus, well, there's no number there, so I write 1. Watch out for that. 3y plus 11, because they do try and trick us. 6 times 4 is 28y. 6 times 1 is plus 6. Minus 1 times 3, minus 3y. Minus 1 times 11, minus 11. And again, we can now see inside our box, we've got 28 minus 3 is 25y. And then we've got 6 minus 11. Well, that becomes 6, 7, 8, 9, 10, 11. That's 5, so minus 5. And we're done there. One last one on expanding and simplifying brackets. We've got 5t. 2t minus 1. Box. Plus 3t. Box. Minus 4t. Plus 1. So 5 times 2 is 10. T squared, because it's t times t. 5 times 1 is 5, so it's minus 5t. 3 times 4 is 12, but it's minus, because it's a plus times a minus. It's minus 12t squared. And 3 times 1 is 3, so it's plus 3t. So that gives us inside the boxes 10 minus 12 is negative 2t squared. And then we've got minus 5t plus 3t is minus 2t. Just collecting all the terms that are like together. Problem solving. Sometimes we have to get a question, we have to write down an area in terms of algebra. So just to show you this, it comes up more in factorizing and solving quadratic equations. What's the area of this box? So, or a rectangle. Area, remember, is length times breadth. So if I just call that the length is equal to 2x. And the breadth of the height is 3x minus 4. So our area is length times height. So I just write that down. 2x bracket 3x minus 4. And then you might expand that because you have to in the question. So you just go ahead and expand that in the normal way. Draw on my box. 2x on one side. 3x minus 4 on the other. That gives me 6x squared minus 8x. So my area is 6x squared minus 8x. And then the question might go on and say, well, x is equal to 2. What's the area? Or it might then say, this area is equal to another area. Can you then work that out and solve it using a quadratic? But wait until you get to quadratics to see that. Here's another one. But quite often triangles appear instead of rectangles. So what's the area of this? So the area of a triangle is a half the base times the height. You should know this. So our base is here. So our base is this, and that's our height. So we can just write down our area is equal to a half of the base, 5w minus 3, times the height, which is 2w. So working out a half times 2 first. A half times 2 is 1, so that gives you w bracket 5w minus 3. And then you can expand and simplify as normal by drawing your box. W, 5w minus 3, 5w squared minus 3w. So we get area is 5w squared minus 3w. And we'll be done there. Okay, let's look at expanding double brackets. So double brackets is when you get a bracket times a bracket. Like this, which is your standard ones. Our teachers teach some tricks for this, like FOIL or other things. I always use my box and then I can't make a mistake. So I'm going to use my box. So if you know a different method, fantastic. Use that method if it's working for you. But this is just a method that if it isn't working for you, give it a go. So I draw my box. So remember, a nice big one for this one. On one side goes my first bracket, so I've got 3x, and I need a space plus 7. So there's my first bracket. And my other bracket is 2x, then plus 5. So I split every time I see a sign. So 2x plus 5 and 3x plus 7. So I end up with 4 answers. I then times everything together. So I'm going to do 2x times 3x, that's 6x squared. 3 times 5 is 15, so that's 15x. 7 times 2x is plus 14x. 7 times 5, that's just 35. Now the advantage of the box here is you can see the like terms. You've got these two on this diagonal are always the like terms for most of the time. So I can just write my answer straight away as 6x squared. 15 plus 14 is 29x. And then I've got plus 35 on the end, just hanging out. And we're done there. Now, example of using expanding double brackets with the area method. So I draw a big box. One side, I've got 5y plus 7. And the other side, I've got 3y minus 4. Split it up into 4. 5 times 3 is 15y squared. 5 times 4 is 20, so minus 20y. 7 times 3 is 21. 7 times 3 is 21, so 21y squared. I'll put the sign on it, plus. And then 7 fours is 28, but it's minus 28. So now my final answer is 15y squared. These two go together, so 21 minus 20 is plus 1. So plus 1y minus 28. And we're done for that one. Another example, we expand the double brackets using that method. So we've got a box. Hopefully you're getting the hang of it now. 6t minus 5, going a little bit quicker. 3t minus 2 times everything together. 6 3s is 18, t squared. 6 2s is 12, so it's minus 12t. 5 3s is 15, so it's minus 15t. 5 2s is 10. Careful, is it plus or minus? Well, it's a minus times a minus, so it's a plus. So our final answer is 18t squared. Minus 15 minus 12 is minus 27t. And then I've got plus 10 hanging around on the end. Here's a special case. We call this a difference of two squares. It's when you've got 2x plus 1, 2x minus 1, plus and minus, but the brackets are the same otherwise. And you'll see what happens. You'll see as well when you get to factorising. You get 2x plus 1 on one side and 2x minus 1 on the other side. 2 times 2 is 4x squared. 2x times 1 is plus 2x. 2x times minus 1 is minus 2x. And minus 1 times 1 is minus 1. So our answer outside the box is 4x squared. 2x minus 2x is 0. So I've got no x's to write, and then I've just got minus 1 in the end. So when you get a bracket where they're exactly the same except there's a plus and a minus, it gives you this squared, 4x squared, minus this squared, 1. Squared is 1. But you can still just expand it in the normal way instead of having to memorise a new rule. Okay, expanding squared brackets works exactly the same. A squared bracket, anything squared means times by itself. So all you need to remember is that this equals 3x plus 2 and 3x plus 2. So we can draw a box. 3x plus 2, 3x plus 2. Split it up. 3 3s is 9, so I get 9x squared. 3 2s is 6, so I get plus 6x. 2 3s is 6, so I get another 6x. And 2 2s is 4, so I get plus 4. So outside of the box, I get 9x squared. 6x plus 6x is 12x, plus 4 on the end. Expanding squared brackets again, so we've got 4a minus 3 and 4a minus 3. Draw a box. 4a minus 3 and 4a minus 3. Splitting it up, we get 4 4s is 16a squared. 4 3s is 12, so minus 12a. 3 4s is 12, so another minus 12a. And 3 times 3 is 9. A minus times a minus is a plus. So outside the box, we get 16a squared minus 12 minus 12 is minus 24a, and then plus 9. Look at an example where there's two separate square brackets. So the first box we can put here is y plus 8 and y plus 8. And then the second one we've got here y minus 3, y minus 3. And just a reminder, we're going to take away at the end. So we get y squared plus 8y plus 8y plus 64. And then we get y squared minus 3y minus 3y. Minus times a minus is a plus. So that gives me 9. So taking that outside the box, for the first brackets, we get y squared. 8 plus 8 is 16y. And then plus 64. And then it's minus all of this answer, y squared minus 3 minus 3 is minus 6y, and then plus 9. So you need to be very careful. You're taking away all of it, so it's like another expansion brackets to do. But you can just do y squared minus y squared, 0y squared. 16 minus minus 6. That's plus 6, which is 22y. And then 64 minus 9, which is 55. So plus 55. And we're done there. Double brackets, what's the area of this? So remember, area of a rectangle is base times height. So there's our base and there's our height there. So we can just say that that is 4x plus 1, 3x minus 2. And we could expand and simplify that using our box method. 4x plus 1, 3x minus 2. That gives me 12x squared minus 8x plus 3x minus 2. Taking it outside the box then, our area is equal to 12x squared minus 8 plus 3 is minus 5x, and then minus 2. Here's another example like that, but this time a triangle. So area is half the base times the height. So for this one, our area is going to be a half of 6t minus 3 to t minus 1. So we'll expand and simplify our brackets first. 6t minus 3 to t minus 1. 6 times 2 is 12t squared. Minus 3 times 2 is minus 6t. Minus 1 times 6 is also minus 6t. And minus 1 times minus 3 is plus 3. So that gives my area equal to a half, don't forget the half, of the whole thing, 12t squared. Minus 6 is minus 12t, and then plus 3 on the end. Or we can expand that if we want to get 6t squared minus 6t, and then 3 times a half is 1.5, or just 3 over 2. And we're done there. Okay, expanding brackets with 2 terms and then 3 terms like this, x plus 5 times 2x squared plus 3x plus 6. Again, no problem here, just use my box, but just being careful that there's going to be much more numbers inside. So you've got x plus 5, 2x squared plus 3x plus 6. Split, split, split. X times 2x squared is 2x cubed. 3x times x is 3x squared. 6 times x is 6x. So just watch out for that x cubed. X times x squared is x cubed. 5 times 2x squared is 10x squared. 5 times 3 is 15x. And 5 sixes is 30. So you should notice that we're getting these two the same on this diagonal, and these two go together on this diagonal. We have both x squareds on the first diagonal. We have both x's on the second diagonal. So they go together. So looking at that, we get 2x cubed as our answer. 10 plus 3 is 13x squared. 15 plus 6 is 21x. And then plus 30 on the end. And we're done there. Here's another example of expanding brackets where you've got 2 terms, then 3 terms. So again, we're going to draw a box. 9u plus 5 on one side, 3u squared minus 8u plus 7, split, split, and split. So 9 times 3 is 27, so we've got 27u cubed, cos u times u squared. 9 times 8 is 72, so it's minus 72. U times u is u squared. 9 times 7 is 63, so plus 63u. 5 3s is 15, so plus 15u squared. 5 8s is 40, so minus 40u. And 5 times 7 is plus 35. So that gives us 27u cubed minus 72 plus 15. That's minus 57u squared. Let's check that. 57 becomes 67, 68, 69, 70, 71, 72. Good. Then the next ones are 63 minus 40, which is 23u, and plus 35. Okay, now let's look at all the past paper questions involving expanding brackets. Usually happens at the start of the exam paper. SQA National 5 Maths 2014, paper 1, question 2 on expanding brackets. Multiply out the brackets and collect like terms. Got a standard one this, so we've got a box. 2x minus 5 on one side and 3x plus 1 on the other. Split it into 4 and begin. 3 times 2 is 6x squared. 3 times 5 is 15, but it's minus 15x. 1 times 2x is plus 2x. And 1 times minus 5 is minus 5. Usually get a mark if you get that far, then collect like terms. So outside the box, you've got 6x squared. These two go together, so being careful, minus 15 plus 2 is minus 13x, and then minus 5 on the end. And we're done there. National 5 Maths 2015, paper 1, question 4 on expanding brackets. Multiply out the brackets, x minus 4, x squared plus x minus 2. Now, if you use FOIL at school, you can't use FOIL for this because that only works for double brackets with 2 terms. So I always use a box so I don't have to think about FOIL. A box, I've got one big box. On one side of the box, I've got my first bracket, which is x minus 4. And on the other side, I've got x squared plus x minus 2. Now I can split up my box in between each term, and we're just timesing everything together. So I'll put the answers in a different colour so it's clear. So we have got x times x squared, which is x cubed, x times x plus x squared, x times minus 2, minus 2x, minus 4 times x squared, minus 4x squared, minus 4 times x is minus 4x, and minus 4 times minus 2 is plus 8. Watch for minus times a minus. Now you should notice that boxes in this diagonal go together. So when I want to get them out the box, I've got x cubed. Then these two go together, so that's minus 4 plus 1 minus 3x squared. Then these two go together, so that's minus 4 minus 2, which is minus 6x. And then I've got plus 8 on the end. And I'm done there. 2017 paper 1, question 4. Very, very similar, so I'll do it the same way. Set my grid up. 2x add 3 on one side, x squared minus 4x add 1 on the other side, times it all together. 2x cubed minus 8x squared plus 2x. And then the bottom, 3x squared minus 12x plus 3. Putting it all together, so our x squared terms becomes minus 5x squared, and our x term becomes minus 10x. So our final answer is 2x cubed minus 5x squared minus 10x and 3. SQA National 5 Maths 2018 paper 1, question 2. Expand and simplify. Well, I always use the box method for this, so I'm not going to stop now. So I've got one set of brackets on one side, 3x plus 1 times x minus 1. So I'm going to expand and simplify that. And then it's plus another box, 2 on one side times x squared minus 5 on the other. So I can now easily expand it using a different colour to highlight the answers. 3x times x is 3x squared. 3x times minus 1 is minus 3x. 1 times x is plus 1x. 1 times minus 1 is minus 1. So there's my first set of answers. And then over in the other box, 2 times x squared is 2x squared. You might want to put a plus and 2 times minus 5 is minus 10, and then taking our answer outside the box in, collecting like terms, so looking at our x squared, so we get 3x squared and 2x squared, so that's 5x squared. Looking at our x terms, being careful, we've got minus 3x plus 1x is minus 2x, nothing on this side, so it's minus 2x. And looking at our number parts, we've got minus 1, minus 10, so that gives me minus 11, and I'm done there. Past paper question 2019, this comes from paper 1 question 3. Quite often these questions will either come at the start of the paper, nice and easy to get you going, or maybe towards the end of the paper when you've had to write an expression yourself. But let's just deal with the simple cases. So we've got x add 5, 2x squared minus 7x take away 3. Hopefully you get an idea now. I draw my grid. On one side goes the first bracket, so I'll put x add 5 down the side, and the other side goes the other bracket. 2x squared minus 7x minus 3, times it all together. I've got x times 2x squared is 2x cubed, x times minus 7x minus 7x squared, x times minus 3 minus 3x. 5 times 2 is 10, so 10x squared, put a plus in. 5 times 7 is 35, so minus 35x. 5 times 3 is 15, so minus 15. Putting it all together in the same way, we will have an answer of, are we ready? 2x cubed plus 3x squared minus 38x minus 15. Expand and simplify. I'll do this in my usual way by drawing a box. On one side goes one bracket, 3x take away 2. And the other side we've got 2x squared plus 5x take away 1. Also, there's lots of ways to do this. I'm just trying to get all the ones correct. So 3 2s are 6, so I've got 6x cubed. 3 5s is 15, so I've got 15x squared. 3 1s is 3, so minus 3x. 2 2s is 4, so minus 4x squared. 2 5s is 10, so minus 10x. 2 1s is 2, so plus 2. Because minus times a minus is a plus. So that gives us 6x cubed. We've got 15x squared minus 4x squared, so 11x squared. We've got minus 3x minus 10x, so minus 13x. And last but not least, plus 2. Okay, next question. 8th grade National 5 Maths 2023. Paper 1, question 2. Expand and simplify. So an expand and simplify question. So we've got x plus 7 squared plus 6 times x squared minus 10. I'll do this in the same way I always do it, using the box method, but you could have done it any other way. So x plus 7 squared means I've got x plus 7 times x plus 7. You expand that bracket. Plus 6 times x squared minus 10. X times x is x squared plus 7x. 7 times x is plus 7x. 7 7s is 49. Plus 6 times x squared is 6x squared. 6 10s is 60, taken away. So now I can just put everything in the boxes together. So looking at the x squareds first, I've got 1x squared plus 6x squared, so that's 7x squared. Looking at the x's, 7 and 7 is 14x, no other x's. So plus 14x. And finally, I've got 49 take away 60. So that's negative 11. And we're done there. Mr. Clelland here from Clelland Maths. So another hard question that we're going to look at this time from a National 5 paper. It was the 2016 paper 2 question 12. So a good few years ago, but quite a common type of question to come up. And it says, the diagrams below show a rectangle and triangle. All measurements are in centimetres. Find an expression for the area of a rectangle for 1 mark. Then, given the area of a rectangle equals the area of a triangle, show that x squared minus 2x minus 8 equals 0 for 3 marks. Then find algebraically the length and breadth of a rectangle for 3 marks as well. Have a look at this and see if you can get anywhere with it before we come back and discuss it and see what the solution is. Okay, so what this question is asked us to do is find an expression for the area of a rectangle, which we'll do in a moment, but essentially it turns into a quadratic question
but also it is going to be, you're going to have to find the expression for the triangle, make them equal to each other, and then rearrange that equation to get that quadratic. Quite a hard skill. Once you've done that, you'll then have to solve your quadratic equation. I'm going to go through a few steps with this and a few pointers that I think might make this a little bit easier, especially if you can't do the whole question. Okay, part A, find an expression for the area of a rectangle. Don't be scared by this. You all know the area of a rectangle is length times breadth. So just write down what the length of the rectangle is. If it was a number, you would write down 4, 5, 6. But in this case, it's x plus 8. So I'll just write down x plus 8. Now, since this is going to be times by something else, I'll put that in brackets. And I need to times by the breadth for the height, which is 2x plus 1. 2x plus 1. So there is an expression for the area of my rectangle for 1 mark. Part B, given that the area of a rectangle equals the area of a triangle, show that this. Now, we'll try to get there, but we don't know how to get there. But it does say area of rectangle equal area of triangle. So we know the area of a rectangle is x plus 8 and 2x plus 1. And that equals the area of a triangle. Well, a triangle is half times the base, 2x plus 5, times the height, 3x. So we can write they equal to each other. So now we need to expand some brackets, and we'll get marks for expanding our brackets if I've managed to write this down. So expanding the left-hand side, I usually use a box. We get x plus 8 on one side and 2x plus 1 on the other side to get 2x squared plus 16x plus 1x plus 8. And that equals a half times 2 is 1. So that's 3x times 1 times x plus 5. So essentially it's a half times 2 is 1, leaving just this to expand. That gives me 3x squared plus 15x. Tidying up the left-hand side, we get 2x squared plus 17x plus 8. And that equals the right-hand side of 3x squared plus 15x. You would get a mark for expanding this bracket and a mark for expanding that bracket. And then a mark for making them equal to each other and then somehow getting it down to the expression that they want. Now, the expression they want is equal to 0, so I need to move everything over to the same side. So I've got small 2x squared, so if I look at the right-hand side, I've got 3x squared plus 15x. I'm going to make this 0. I'm going to take away 2x squared then. I'm going to take away 17x, and I'm going to take away 8. So 0 equals 3x squared minus 2x squared, which is x squared. 15x minus 17x is minus 2x, and I've got minus 8. Or to put it in the way they want, x squared minus 2x minus 8 equals 0. Now, you couldn't get very far with this question if you couldn't do part A. And if you could even do part A, but you couldn't write down an expression for the triangle, or just didn't know what to do, you couldn't do part B. That doesn't stop you doing part C though, because part C then says, hence find algebraic with length and breadth of the rectangle. And the question already told you that x squared minus 2x minus 8 equals 0 in part B. So even if you've lost the first two parts, you can still, if you know how to factorize and find out x, work out this from using quadratics. Okay, so you either got a quadratic formula or you've got factorizing. Now, since this is non-calculator, you can bet 9 times out of 10 we're going to factorize. So let's have a look at it. We have got x squared minus 8x, 2x minus 8 equals 0. You're looking for, just to factorize this, numbers at times there to make 8. So I've got 1 and 8 or 2 and 4. And I want to pick the pair that add or take away to make minus 2. Well, 1 and 8 never does it, so it's going to have to be 2 and 4. And then I just write down, how does that make minus 2? Well, it makes minus 2 by doing, it's not going to be 4 take away 2 because that's plus 2. It's going to be 2 take away 4. Or plus 2 take away 4 is minus 2. And plus 2 times minus 4, just to check, is minus 8, which is the last number. So I can now factorize it. and a lot of this you could have done without any working. X and X, I've got +2 in one bracket and -4 in the other. You get a mark for factorising. And then for solving, you can then say x plus 2 equals 0 or x minus 4 equals 0. So that gives me the x equals -2 or x equals 4 for a second mark. And then because this is a question in context and we're talking about actual lengths of the triangle and rectangle, if we go back up and look at the lengths, we've got x add 8 on the rectangle. Well, that means that we've got 4 plus 8 and we've got -2 add 8. And then on the other side, we've got 2x add 1. So that's 2 times 4 is 8 plus 1 is 9. But then you'd have, if you use the -1, -2 plus 1. -2 times 2 is -4 plus 1, which is -5. So we can't have a negative x because it's going to give us a negative height or breadth, and that doesn't work. We can't have a negative length. So we have to pick the one that's going to work. So using x equal to 4, the length is equal to, so remember back at our triangle, eight plus 4, which is 12 centimetres. The breadth was 2x add 1, so 2 times 4 plus 1, which is 9 centimetres. And we get our final mark for working that out. It's been Cleland Maths today. We've looked at another hard National 5 Maths question, this time from 2016, paper 1. Hopefully that was helpful for you. Take care, stay safe, and goodbye.